Here we have a system of equations with three variables, r, s, and t, and three equations. So let's go ahead and use substitution for this. Let's go ahead and solve for t up here because it's almost by itself. So what we're going to do, in order to isolate the t, I'm going to put the t on the right side where it will be positive, and I'm going to bring the 20 over to the left side where it will be negative. So what that will look like then is t equals negative 3r minus 6s minus 20. So now I'm going to use this expression, negative 3r minus 6s minus 20, and I'm going to substitute it into the other two equations each time I see t. So here's a t and here's a t, so that's where it's going to be substituted. So let's go ahead and look at that second equation, negative 5r minus 2s minus 4t, but t is going to be this expression, and that equals 0. So I'm going to go ahead and take a moment and simplify this and just kind of put our like terms together. Okay, so my r's will be 7r plus 22s, and I'm going to take this positive 80 and bounce it on the other side to make a negative 80. So that's going to be one of our equations. I'm going to take the third equation here and do the same thing. And where I have the t, I'm going to place this expression in there. And that equals 7. Okay, so same thing. I'm going to go ahead and simplify this down. I'm going to do my distributive property first. That'll be a negative 9r. And then combine like terms. Negative 14r, negative 13s, and I'm going to put that negative 60 on the right side to make 67. Okay, so I use substitution here to take my system with three equations and three unknowns and whittle it down to two equations with two unknown values. So I'm going to go ahead and write these two equations down over here. And we have negative 14r minus 13s equals 67. Well, this doesn't look too bad because it looks like my r's could almost cancel out the way they are. I just need to multiply the top equation through by a 2. So 14r plus 44s equals negative 160. The second equation is left unchanged. So what it looks like are my r's are going to cancel, and my s's are going to be a 31s, and that's going to equal a negative 93. So when I divide both sides by 31, s is going to be negative 3. Okay, so I can go ahead and I could plug this s as negative 3 back into one of these equations. Let's go ahead and choose this second one. So negative 14r minus 13 times negative 3. So it's negative 14r plus 39 equals 67. When I subtract 39 from both sides, I'm going to get 28, and r equals negative 2. So now I have s and I have r. So where should I plug these back into? Well, the expression that we had at the beginning already had t isolated, so I can substitute r and s right here to get the value of t. So let's go ahead and bring that down here where I have a little bit of room. So I had t equals negative 3r minus 6s minus 20. So t equals negative 3 times my r value, negative 2, minus 6 times my s value, negative 3, and then minus 20. So t equals 6 plus 18 minus 20. So 6 and 18 make 24 minus 20 is 4. So I'm going to write my ordered triplet in alphabetical order, r, s, t. So r was negative 2, s was negative 3, and t was 4. And this ordered triplet represents the solution to this system of linear equations.